Trapped in the concept, falsely accused, was used, and misled, bitch, I'm hoping you fuck.
Welcome to my YouTube student guide for NX MLP and CAM templates. So in this video, it's going to show you what NX MLPs are and CAM templates. It's also going to show you how to create your own CAM template and also how to create your own process plan. So CAM template is a way to either create geometry in a model or set up a model for a CAM operation. So a CAM template is just a set of predetermined parameters, and this can be for either like a tool or it can be for an exact setup, and the tool could have the tool dimensions and the speeds and feeds needed for that exact tool. And in this example, we're going to go through making a tapping template. So let's go. So welcome to the CAM template. So first I've made a geometry, and this geometry has holes in it of 10 millimeters, and you can make this geometry before. Next, you have to make sure it's a manufacturing file. So make sure you're in NX manufacturing to do this. Then we're going to make sure we know what the workpiece is. So we specify the part and we specify a blank. Next, what we're going to do is to create a geometry. So we're going to use hole making to make this geometry, and we choose hole boss geom. Now we're going to change the name to what we're making. So we're making an M10 tapped hole. So we change the name to that, as this is the geometry all the tools will be kept in. So next, when that geometry is made, we're going to select the geometry it's actually going to be affecting. So we select those 4 holes that we have in there prior. So after those are selected, we press OK. And in this, we can now start making our operations. So we want to start with the spot drill, as we are tapping. So we click the spot drill, make sure we keep everything the same, and make sure the geometry is M10 tapped hole. From here, we want to click on tool, create a new tool, and retrieve from tool library. And we want to go into drilling, and we want to select a spot drill. So we'll select a spot drill that we need to use. So press OK. And here we can select the 10 millimeter spot drill. Press OK and press OK. And then we can press OK for that. From this, we don't need to generate the toolpath yet. Let's create a new temp operation. The next operation is going to be drilling. Everything stays the same, and press OK. So we now go in, create new tool again, select from the library drilling, and we want to go twist drill. After this, we want to press OK, and we want to select a 8.5 millimeter drill, as we are tapping an M10. Press OK for that, and press OK. No need to generate. Go to the next operation, go to tapping, go to keep everything the same method, tools, create new, go to the library, drill, and we want to go to tap. Press OK, press OK, and now I want to select the M10 tap. Press OK. Everything is now created, and we press OK for everything. Make sure we take out gouge checking, and now we can generate the path for everything. Accept these paths. So next, what we're going to do is to look at everything and make sure everything's cool. And then now we can go to the file, and this is the most important part, saving our workpiece, because we need to save it in the right area and under a name we can remember and reference to. So go to program files, go to Siemens, NX11, and pick Mac. Next, resource, So make sure you pick resource and then go to template part, metric, and here we're going to make our part file. So this is where we're going to make the template part file. So I'm naming it here. So you can name it whatever you want, but make sure to remember this name as you're going to reference back to it. So always make sure it's a name you can easily remember and it's something you can type out consistently. So after you've made it and kept it in this file, you've now made your own file template. This is a template file now. So what we now need to do next is the template settings. So first of all, go to the workpiece and we're going to go to Object, Template Settings. Make sure both of these are clicked as the workpiece is the overarching thing. Go to the Geometry, Object, Template Settings for that as well. Make sure it's only the top selected and that's it. And for the three underneath, select all three using the Shift button and press Object, Template Settings, and you want to make sure it's create if parent is created. So when it's opened, they get created automatically, and make sure that's all done. So next we're going to go to the files so that we can save everything in the back door of NX so everything can show up. So what you're going to want to do is go to your PC, then go to your local disk C, program files, Siemens, NX11, Mac, resources, and template directory. After you've gone through those steps, you're going to go to your template.dat file. Open that up, and when you do open that up, it's going to come up with this, and these are all the files that are in NX. So what you're going to want to do is to find the whole making line, which is 112, copy and paste that, as that is the pretty much the same what we're doing. So it's the same or similar to what we're doing. You're going to want to go to the bottom, and at the bottom it says setup templates can be added by the user. So what we're going to do is make a new line and paste in that same line, and we're going to make some changes to it. So we're going to change it, and remember it says it has to be greater than 200, so we change us to 207, and then we also make some edits to the name. Make sure the name you saved your file as is the name you put into here. So ours is tapping 101, so tapping underscore 101. You make a change there, and you make a second change in that line, and again, all these names have to be coherent for this to work. If the names aren't the same, it won't work at all. So after these names have been changed, you can file and save, and make sure you have access to change things in this file. So you might have to change some of the permissions, but when you get access, you can save these files. So after close that, so before you make this change, make sure you make a copy of the template.dat file that is a backup and is unchanged, just in case something goes wrong. Now we go back to Mac, resources, and we click template.set. Here we want to change the cam general OPT file. So we want to open that up, and we want to scroll down, and we want to select the whole making line again, as this is the similar operation to ours. Want to make a space underneath, copy and paste that in, and again we're changing the name of this to the file name we made prior to this, and mine is tapping 101. So after we make that, you can save this as well. Again, you need permissions to save here, and also make a copy of the cam general file prior to changing it. After that's been changed, what we now need to do is to go to our menu, Preferences, Manufacturing, and this is where we refresh and tell NX there's been a change in the file and it needs to reread those files. So we reset those files and press OK. So we now open up a new window. I've got a practice piece here, and this is just a block with a hole in it, a 10mm hole in it, and this is going to be where we're going to practice how our template would work. So we create a geometry,
And when we create a geometry, it's going to be manufacturing. We open that up, and there you can see it tapping 101, what we've made. Select that, and there we go. Our M10 tapped hole geometry is there. We select that, and we make sure, press OK. And then now we want to select geometry it's going to be affecting. So we click the hole that we want those toolbys made for, press OK. When we click down, everything's been made. So you can see how easy that is. All the drill, the spot drill and tapping's made. You can generate all of that, and you'll pray OK, accept the paths, and everything's been made for you. It's a lot easier than doing everything individually. Now we can verify everything. First here I need to apply a blank to this before I can make it work in 3D. So I'm making the blank. So I apply the blank to the object by making it a bounding block. After I apply it, I'm now able to run the simulation. I regenerate these toolpaths, press accept, verify the toolpath that it's going to work, and everything works. So that's how you make a cam template. So if you need to make a cam template, these are the steps you need to follow to make it properly. Thank you.
So now we're going to go into NX Machine Line Planner. So NX Machine Line Planner is a software which is for high volume production of complicated parts with many features. Machine Line Planner combined with integrated NX CAM software enables distribution, balancing, programming, and simulation of operations over multiple setups and machines with different tools. This integrated solution allows for bi-directional change management between the programming and the line planning. So you can make different changes and you can have different setups. And these different setups can converge into one final product. So next, we're now going to show you how to make or go about starting a machine line plan and what steps need to happen prior before you can start one. Okay, let's go. So, okay, this is the next part of the tutorial. So this is the part where we're going to utilize NX MLP to make our next model. So this is the model, and as you can see, it has the two features on it. And in this model, what we're going to do is to utilize it to help us to make what we need to and make sure that you've already modeled your part. So we're going to go into window, and you have to make an assembly for this. So this has to put into an assembly and it has to become the child of the assembly. So make sure that you have all the assembly parts in. So after this, and after you've made sure that it's in an assembly and everything is kosher, we're gonna move on to making the blank and setting all the parameters. So you move into the geometry part of the manufacturing, and we want to press edit on the workpiece so that we can define or identify what the workpiece is and what the blank is. So you can see here in the video right now that we're identifying it and a blank has been made, but we're going to have to go back into that initial parts file and make a blank in there. And this is due to needing it to be a geometry when you have to declare it in the assembly file. So you make a blank here using the bounding body function in NX, and when you do that, you click on it and you make the bounding body, and that's perfectly made now. So from there we can go back into our assembly file and redefine it in the workpiece, but now we can select it as a geometry, as this is the only way that NX MLP will allow for you to put it inside machine line planner. So now we have to identify it as a geometry and everything should be all right. So this is our part, everything's good. So now what we're going to move on to is to opening a new file, and there you can see machine line planner. Make sure you've picked on process plan and then we select OK. It's going to open up machine line planner. Now this is machine line planner as you can see it. Everything's there for you. You can open that up and stretch it out. So what we want to do now, that's the load process, and we're going to load our initial part that we've already made and make sure we're loading the assembly file. So we go in, and as you can see, we have our model and we have our assembly. We want to upload the assembly as this is the only one that will be allowed in. So now the assembly should load up and see, perfect, showed up. So this is the actual program. You've got your part inside machine line planner now. You can take a look around as that is the initial part, and we're going to make increased setups that will change that. But this is the initial master part that will not be changed or touched, and it will be kept there. So what we want to do now is add a setup. So we're going to add a setup, and as you can see, it duplicates your part, and your part is now right there. So from this, you can see that you can add as many setups as you want when you want. So for this setup 1, we're clicking on it, zooming in, and this is the part we can now change and make edits to. So what we're going to do now is to open it up in CAM manufacturing. So open up with manufacturing, and you can open it up, and from here it's now gone into setup 2. As you can see at the top, this is just part setup 2, and we can make changes in here, and all these changes will be reflected in the actual process plan. So now we can make all our functions, our processes, our operations, and geometry to it. So what we're going to do now is to add some operations to this. We want to make the hole at the top. So what we want to do is to use create a geometry, and we can actually use the CAM template we've made prior in this video. We can actually apply it to this. So what we're going to do is actually create a geometry. So we go to create a geometry and we open that up, and then we go to the hole, that tapping we made, open that up, M10, tapped, and that's perfect. And this is one of the uses for a CAM template. It makes things a lot easier and quicker. So you can even utilize it in NX MLP. We click our hole, and when we click our hole, we press OK, and perfect, it's done. All the tapped hole parts have been made, spot drilling, drilling, and tapping, all showed for you right there. And what you have to do now is we're going to generate the toolpaths, and everything should be Gucci. This is a simplified model. Obviously, people are going to have more complicated models, but this is a simplified model, and we've accepted the paths, and everything's been made for you. So that's it, showing the advantage of CAM templates within NX MLP. So next, what you want to do is to actually just go back. Everything should be automatically saved for you. So you can just go back to your window, and you can open that up and go back into that initial process plan. So first of all, you can first simulate and verify parts, but we can actually go back into the process plan. And now you can see under setup 1, all those parts have come in. And it's really good that you have this, as you have that source set up there and that target set up, and you can move these back and forth. If we go to target setup, they are all in there, but we can now move that back and forth due to the dependencies we make. So those items up there that are highlighted in yellow, those are dependencies, and you can see sequence constraint, a time filter, tool capacity filter, and a direction filter. So all these can be moved and changed due to what you want and the constraints you apply to it. So like I said, move around, play around with NX MLP, and you get a lot better at using it. So what we want to do next is to make that second setup, because this is supposed to be a multi-setup program. And I told you we have two features on two different sides of the part model. And this is due to the fact that if you only have a 3-axis mill, you can only mill one side at a time. So the technician's going to have to move it. So this program helps to show you how it will be moved and the changes that are made. So what we want to do next is to add another setup. So we add a setup, and again, that same piece is showed again. So from that, we're going to now edit setup 2 and go into the cam and add things to it. So we've gone into setup 2. No, we've gone back into setup 1, but we're going to go back into setup 2 to do everything, but we want to verify that everything works now. So this is just a verification step. We're going to decrease and just show that this works. And this is how we're going to show that the IPW flow works. So the changes we make onto this piece are reflected onto the next piece. So you want to run this verification. Everything works, as you can see. So we're now going to go back into process plan and go back into setup 2 and set up the IPW flow so that everything works perfectly. So we go into workpiece, and I'm saying do not change that workpiece. That workpiece stays the same. It's very vital that you know that. Don't ever change that workpiece. That workpiece is the same throughout all the time. Next, you want to make sure all the IPW flows are working, and you should be good. So how we're going to do this is, first we're going to move the component. We want to move the component over to its side, so we know that that's the top face that we want to edit because of due to the tool axis. So I'm just moving it around now. It's at a 90-degree angle. And when it's at a 90-degree angle, everything should be all right. So now that's a 90-degree angle. Just check it. That's the right way up. After it's the right way up, it's done, and that's perfect. So what we want to do next is to make sure IPW flow, or the changes we made in the previous setup in setup 1, has been reflected in setup 2. So you go into the geometry and check the IPW. So what you want to do is to refresh it and make sure everything is all right. So the way to do this and to make sure is just by doing that, and everything should be good. Now we want to make our operation. We're creating a new operation, just floor wall, and we're going to bore out that top part. Again, this is just a demonstration, and this won't show you exactly how to make it perfectly, but it will show you how to bore out the top and make sure it's all good, and just how to do things. So now you can select everything and put in your dimensions, your parameters, your cutting parameters, feeds and speeds, and there's a lot of things you can put in there when you run it yourself, but this is just a tutorial. So I'm going to pick up a tool that I want and need, and everything should be good. Right now the IPW does have an issue, but it will be sorted later when you update it, and I'll show you how to do that properly. But first of all, we want to click on the tool and find the new tool. So we just get a tool from the tool library. So it's been shown here. We go pick up on a tool. You pick a random tool that you want to use. Again, when you do yours and when you do it on your model, you're going to pick a tool up that you want to use. Okay, so now that's all done. What you want to do now is to press OK. And the next thing you want to do is to, now I've got an IPW issue, so it won't run. So when I tried to run and verify this, it didn't want to because I had an IPW issue, and this IPW issue can be fixed by going back to setup 1 and making sure you update it. So you update the parameters in setup 1 so it can be reflected in setup 2. So what I'm going to do here is to edit it and try to update the IPW, and I'm checking if the part geometry is right. Then I go to IPW and I want to make sure that it's taking it from the right source, which it is. and everything should be all right. But I'm going to go back to setup 1 to see if there's any issues. So we're going back into setup 1, the one we made the drilling operations in. Go to that, and we're going to go into its blank, and we're going to check if all the IPWs are correct. And when everything's good there, you can come back to here and you can refresh the IPWs, and it's all good. And you can see that there is a change there, and you can see the blank in red right now. So you can see the drilled hole at the top. So the IPW has now been updated. So like I said, when you want to update the IPW, you have to go back in setup 1 and make sure that's all updated. Now, when you try and run and verify, the floor wall will happen. And now we can run a 3D simulation to see what would happen. And it's a quick one. It's not a clean job and it can be optimized. But again, this is just a tutorial. Okay, so now that that's done, I've just shown you how to do a multi-setup. So that's just to, again, you can add more setups, you can do more things, but that at its core, this is what NX MLP is. By adding 2 different setups, you can see everything that we did in setup 2 has showed up on the screen. And now when you look at the production line, you can see that change where in setup 2, it's now up straight upwards. And in setup 1, it was another way. So it's a way to make changes, and you can add different products into it, different models into it. And there's a lot of plethora of things you can do. So like I say, it's just for you to mess around and look through it. So what we want to do now is we can look at the setup 2 in the target setup. There is the resources you can look into. You can look into the products, and that's like the machines that are being used and the operation sets. So this is just a tutorial, and like I said, when you use it, you have to play and use it, play around with it, make sure you understand what things do. So now what we want to do is, next after you do this, you can post-process. Post-processing in an NX MLP is still not optimized. You still have to post-process in each setup individually. So we have to go into setup 1, we have to go into setup 2, and post-process them individually, which isn't fun, but at least all of this is all here and it's coherent. So you can go to the Wolfson Horoco 3-axis mill, as this is what's available at my school right now. So when you click on that and you press OK, it will output the actual G code needed, and that's what you would give your actual technician at the shop floor, and they'll be able to run everything and make your part. As you can see, the G code there. And this is the post-processing part and the part after you finish your setup. So you go into post-process, click on the machine you want, and you can do that. You can also apply this to when you change from a generic machine into a normal machine, so you can actually add machines onto your timeline and make changes that way. So that's pretty much all you can do here. So, and there are other operations you can do, like splitting operations and things like that. So that's pretty much it.